Okay, so this is the Key Stage 4 unit, keywords for the chemical changes topic. Produce H plus ions. So anything that produces H plus ions, right, and it also has a pH of 0 to 6 is definitely an acid. Produce hydroxide ions, OH minus. They have a pH range of 8 to 14. Notice our 7 isn't in there because that is then your neutral. That's an alkali. A separation technique used to produce solid crystals. There's a clue, right, by evaporating off the solvent. So you've got your evaporating basin, you've got a liquid in there, get rid of the solvent in there, that is crystallization. A chemical reaction which more reactive element takes the place of a less reactive element, displacement. Okay, so it's the tougher one takes the place of the weaker one, displacement. The splitting up of an ionic compound using electricity. Okay, the equipment often looks like that. You've got two electrodes going in. Electron current passes through a substance causing chemical reactions of the electrodes and the decomposition of the material. That is electrolysis. A solution containing free ions from the molten or dissolved ionic substance. The ions are free to move, so it's that liquid there. That is called the electrolyte. A technique used to separate a desired substance when it is mixed with others. So what you're doing is you're extracting something. A separation technique used to separate solids from liquids. So you've got your filter funnel like that, filter paper in there, you pour your liquid in the top, and what it does, it takes out your insoluble solids, filtration. The electrode where hydrogen is produced if the metal in the electrolyte is more reactive than hydrogen. It is where positively charged ions gain electrons, so the reactions. So you've got your electron substance, so that's positive. Okay, that is a negative, and the negative one is called the cathode. The reaction when an acid and a base react to form water and a salt. Okay, so you've got an acid and a base, they react, and that's called neutralization. A reaction involving the gain of oxygen, it is also the loss of electrons. Okay, oil rig. Oxidation is loss of electrons. Oxidation. It is a measure of the acidity or alkalinity of a solution. Okay, and it can be used to measured using universal indicator, which is the pH. The electrode where oxygen is produced, so what we've got is our equipment again, there's our electrolysis equipment, we've got a positive electrode, we've got a negative electrode. Oxygen, because oxygen is 2 minus, it goes towards the positive electrode. Positive electrode is the anode. Okay, so we've got panic. Okay, I should have put this one on before really. Positive anode, negative is cathode, so positive anode. A reaction where both oxidation and reduction occur is redox. Look at that, redox, oxidation, redox reaction. A reaction involving the loss of oxygen, it is the gain of electrons. So panic, positive anode, that's the wrong one, oil rig, oxidation is loss, reduction is gain. Metals less reactive than carbon can be extracted from their oxides by reduction with carbon. This is completely ionizing an aqueous solution, right? Examples are hydrochloric, nitric, right? So what you got is you've got a liquid and it is completely ionized, so that all the H pluses come out of it. It's a strong acid. Metals are arranged in order of their reactivity, so often it starts with potassium and ends with gold, a U at the bottom, and then you've got all the other elements in there. And it can be used to predict products from a reaction, the reactivity series. A mixture of dyes that change colour gradually over a range of pH and is used for testing acids and alkalis, universal indicator. This is only partially ionized, so where I've got this diagram here, right, what you do is you only get some of the H pluses. That's ethanoic, citric, carbonic acids is a weak acid. Okay, lots of words there for you to get into your head. Test yourself now, pause the video and make sure you're writing them down onto a piece of paper. do it again, right? Make sure that you're doing it again, write it on your piece of paper, and make sure that first piece of paper isn't visible. Okay, so well done. Some good words in there, right? But again, every single time I say this is do it again at some point in the not too distant future, okay? Because it's got to make sure that it's embedded in your brain.